All right, welcome back. In this lesson, I'm going to show you what happens when you reflect light off of some curved mirrors. So first of all, if you can remember, the law of reflection stated that the angle of incidence is always equal to the angle of reflection. So those two angles are always equal to each other. So if you remember drawing ray diagrams in a plane mirror, you always draw a normal line. So when you have a plane mirror like this, when you have a ray coming towards it, you always draw a normal line, a 90-degree line like this. And normal lines we usually draw using dotted lines, so you don't confuse it. Even though it's in red in this case, if you drew it with a pencil, we always draw it as a dashed or dotted line because then you wouldn't confuse it with an actual light ray. And so this angle equals this angle, and your reflected ray should be around there. Okay? Now, that's basically how it works for a curved mirror as well, because you have to think of a curved mirror as, or any curve, as being made up of thousands and thousands or even millions or infinite numbers of flat surfaces. Okay? So if we look at a curve, let's say like this, and again, let me just fill this part in just to show you that nothing goes past that point. If we have a curved mirror like this, it is actually made up of lots of flat surfaces. So we can draw flat surfaces, an infinite number of them. If we draw an infinite number of them, they actually start forming a curve. So every point along this curve, you could actually consider a tiny, tiny flat surface. And so that's an important thing to think of when you're doing this. Just consider it like a flat surface, and then you're just following the law of reflection for a plane mirror. It's the same deal, except you have to imagine that there's a flat surface there. Okay? So this mirror in particular is called a convex mirror. Let me use a different color here. Convex mirror. And then the other type of mirror that you might see is called a concave mirror. And it would look like this. This is called a concave mirror. And an easy way to remember that is that this one kind of is, you're reflecting light off of the cave side, the caved in side. This one is just the opposite of that, and this is called convex. So you're reflecting off the convex side. And quite often these mirrors come with two sides, much like a spoon. And if you take a look at a spoon, the next time you're drinking your soup or eating some rice or whatever, take a look at your spoon and be able to identify which side is convex and which side is concave. The side that curves in, the side that you actually use to hold your soup, would be the concave side. The back side we would call convex. So when we're talking about mirrors, we've got concave and convex mirrors. It depends on which side you're reflecting light out of. So the convex mirror, this one here, quite often you see them on the roadside or outside of a driveway or the corner of a store. And that is because when light reflects off of it, it tends to reflect at very sharp angles. So if somebody was like on this side of the store trying to steal something, shoplifting, well, then the store owner should be able to see them from a large angle. because that light will reflect off there and then into the person's eyes. And then the shop owner can call the police. And so you see them also on the side mirrors of a car sometimes, because it reflects light at a wider angle. And of course on a driveway, because when you're coming out of the driveway, none of you drive, but when you come out of a driveway, you want to see that there's nobody, crossing the sidewalk or no cars coming by. So you want to have that extra reflection from a wide angle for safety. Concave mirror, I can't actually think of a good example that you see every day, but there are concave mirrors being used, and you can think of your spoon as a concave mirror as well. So let's take a look at examples of reflection off of let's start with a convex mirror. So let's draw a convex mirror. Let's draw it on this side. So this is our convex mirror, and that means this side, no light's going to get through here. If we reflect light off of this convex mirror, let's say it goes into that point of our convex mirror. Well, like I said, we need to think of this as having lots of flat surfaces. So what would the flat surface look like right there? So I can kind of estimate, basically turning this into a plane mirror. So there's my flat surface, and therefore I can draw a 90-degree angle line, a normal line to that flat surface pretty easily. Right around there. And so there's my angle of incidence. And here is my angle of reflection. And so those two angles are equal following the law of reflection. So I would expect my light ray to reflect off at that angle. That's not super accurate, but it's good enough, given that I'm not using a protractor or anything. Well, let's say I'm going to fire a light at this curve from down here. We can do the same thing. Where is the flat surface here? So a good way to find a flat surface is actually to take a ruler and see kind of where the balance is on that one point where the light hit the convex mirror. Or just kind of estimate. You remember we drew all these flat surfaces along here? What would this flat surface look like at that point? Once you have your flat surface, then you can draw your normal line going out. Draw and label your angle of incidence. Draw and label your angle of reflection. And now that we have our angle of reflection, we can draw the reflected ray. And so you would expect the light to bounce off that way. Now let's draw one more. Let's say we have a light that's going straight into the middle of our convex mirror. At that point, I think we can say our flat surface looks like that. Our normal line would be right along the incident ray. And following the law of reflection, right now you can see the incident ray makes no angle, 0-degree angle with the normal line. And so you would expect the reflected angle of reflection to be the same, which is 0. So it will go straight back at the source. Okay. Now let's take a look at a concave mirror and what happens. So let me draw a concave mirror. Let's draw it over here. And let's just indicate that this is concave and this side the light does not go through. I'm going to draw a light ray hitting that concave mirror, let's say from here. So there's my incident ray. Now at this point where the incident ray touches the concave mirror, see if you can estimate what that flat surface might look like. I would say it's kind of like that. Okay, so the flat surface should lie, if you drew a line and it touches most of that point, or the parts around that point of that concave mirror, then that's probably your flat surface. And then you have to do your normal line. And just like I said before, if it helps you, you can grab a post-it note, like this one I'm magically creating here, and then, oops, move the wrong thing. And then you can just, oh, it's not working. How do I rotate this thing? Oh, there we go. Okay, so then you can just line it up along the flat surface, along the red line on one side, and then the other side is your normal line. So right there. Having a bit of trouble picking the right object to move here. There we go. Okay, so now there's our angle of incidence, and our angle of reflection, and there's our reflected ray. Okay. Now let's say we have a light ray, an incident ray, that hits our concave mirror at that point there. I'm going to draw a normal line. I don't know how our post-it note changed color. It's kind of weird. Okay, there's my flat surface. Normal line, 90 degrees to that would be like this. Again, you can use your post-it note if you want. And then I can see the incident ray would be here. Reflected ray would be there. And probably, sorry, angle of reflection would be there. And there's our reflected ray. Okay, and what if it hit it dead on in the center? There's my incident ray. Normal line, probably along the incident ray. So that means a reflected ray would go straight back. Okay, so that kind of shows you the different possibilities for curved surfaces and reflecting light off of curved surfaces. So it's a little bit different from a plane mirror, but you can think of it as just the same. Just find that flat surface, draw the normal line, and follow the law of reflection. Good luck.